We have with us Dr. Adrian Keppler, Senior Advisor by HNZ Management Consulting, who will be talking about AM in future.
Again, good evening. Happy to host you at our conference, and
Pleasure.
uh, and can you just brief about yourself and your experience on the technology?
Yeah.
From we can start from that.
Yeah. So my name is Adrian Keppler, and I joined the industry in 2009. And I hope you see in my background, I joined a company called AOS, and AOS is a world market leader in 3D printing technology, and AOS is a pioneer. During that time in 2009, everybody was talking about rapid prototyping, so not about 3D printing. It was all about rapid prototyping, and it was a very hard fight to convince customers about the right part quality, about the capabilities of 3D printing, about the materials, size of the printers. So a lot of uncertainty, a lot of questions. And 10 years later, 3D printing is on the agenda of nearly each and every top manager. So this is a great achievement. So everybody knows that 3D printing can help to speed up time to market. It can help to generate additional customer value. It can help to ramp up production faster. It can help to flexibilize manufacturing assets and so on and so forth. So there's a lot of benefits which a lot of company leaders are aware of. And now it's up to us to leverage that potential and to ensure that we can penetrate the market with the technology. Today, the market is in a range of, I would say, 10 billion US dollar. And if you compare it with other technologies, then it's only a small portion of the overall market we could address with our technology. And predictions are good. So the outlook is good. Experts say that the market will grow by 25% each and every year. This would mean the market would be much bigger than 100 billion US dollar in 2030, but we have to do our homework.
Thank you, Dr. Edi. So can you give us certain examples of bigger OEMs who have adopted with different business ideas for AM? So just wanted some of the names of bigger organizations who have adopted.
So you always have to be careful with dropping names of big OEMs and big customers, because this topic is sometimes quite sensitive. But you can read in the internet that there are companies out there like GE with the famous fuel nozzle, and they changed the part, but at the end they changed the performance of a complete engine. And this engine, the Leap X engine, is now the best-selling engine in the market because it's performing better, and it's performing better because there are 3D printed parts inside which make the difference. Same with Siemens in their gas turbines. Same with companies like Zimmer Biomet, Johnson & Johnson, Stryker, who are revolutionizing the medical implant market by using 3D printing technology to offer additional value by lattice structures on a hip implant, which allows better bone growth and osseointegration. And there are a lot of examples where innovative companies use the technology for their advantage.
Sure. So, but how do you see this pandemic world we are living in? You might be knowing the current situation India is in, and Europe was like a few months back itself. And how do you see the pandemic has changed the adoption of additive manufacturing? And how do you see that in the post-pandemic world, how the technology will be taken up? Because additive was one of the great path-breaking technology used during the pandemic itself. So how do you see businesses shaping themselves up post-pandemic itself?
Yeah. So first of all, we see every evening in the news how the situation is in India, and I hope that it will become better very, very soon. So I wish you all the best for that. And honestly speaking, it's a little bit better, but not much better in Europe. But coming back to your question, so during this pandemic, we learned one thing. We learned to use digital tools. Yeah, and I think 3 years ago, it would have been difficult to have such a session. Now it's more or less normal. It's part of our daily life. My wife, my kids, even my grandmother knows how to use Zoom, or how to use MS Teams or whatever. So digitization is becoming part of our normal daily life, and digitization will also become part of our business life and also part of the manufacturing value chain. So digital manufacturing will be part of each and every factory in the future. And this helps also to penetrate with 3D printing, because 3D printing is a truly digital technology. And you can leverage all the advantages, whether it's a degree of freedom in the design, whether it's flexibility, whether it's optimizing, lightweighting the parts, but also using a distributed network of printers to manufacture close to the customer, to reduce logistics costs, and so on and so forth. And this is what we learned is necessary in an interconnected world, that you do not have just 1, 2, 3 big manufacturing hubs in, I don't know, China, that you have a more flexible, a more agile, a more resilient supply chain. And 3D printing can make a difference, can add a lot of value by, let's call it distributed manufacturing, where you send around a data file and print it close to the customer and do not send around the part. So this will change, and I think the speed of change has accelerated due to the COVID-19. Nevertheless, the basis is the 3D printing technology, and this basis must be firm, it must be stable. And this is, what do we mean by stable? So the technology has to be reliable, it has to work. It has to work 24 hours a day, 7 days a week. The results have to be repeatable. Whatever you achieve in printer number 1, you have to achieve in printer number 2, whether the printer is in India or is in Germany or the US. So repeatability is very important, and also scalability. So you have to be able to scale then your operation, and scalability is also mainly driven by cost per part. It has to be economic. It has to justify a business case and an investment decision. So this is the homework of the technology companies, the printer manufacturers, the material manufacturers, the software companies, to develop a stable technology base on which service providers, contract manufacturers, OEMs then can develop their business, use the technology to manufacture the applications they want.
Thank you for this. So people talk about a lot of exciting stuff to be done in additive. A lot of news comes around about a lot of exciting thing in the engine side, in the gas turbine side, in the medical side. But the business or the money is mostly in the mundanes. So mundanes are those trivial components or trivial business ideas, which makes a lot of money for people. So what has been like the greatest mundane you have encountered in the field of additive manufacturing till now?
So the additive manufacturing, the sweet spot today is mainly, I would say, 80% in the area of high value, low volume components. What do I mean by that? These are components which are complex, which are normally expensive, which are heavy to manufacture, difficult to manufacture. And normally these components you can find in industries like medical, like aerospace, like IGT. There is a second area where we see a strong penetration, and this is an area where the technology can produce parts which offer a high end customer value. For example, by customization, eyewear. If you customize eyewear, if you customize footwear, if you customize protective gear, or another example, dental application, dental restoration. So these are then areas where you have lower value and higher volume. But today, we haven't seen a huge penetration of 3D printing into high volume industries, with a couple of exceptions. But I think there are technologies out there who will increase output and reduce cost per part. Just a couple of keywords. Jetting technologies, multi-jet fusion, HSS in the polymer area, where you have performance increase, throughput increase by factor 5, 10, maybe 15 Also on the metal side, indirect metal processes like binder jetting, LMM, where you also increase productivity by a factor of 10. These are technologies which will help to reduce cost per part significantly. And this will help to penetrate also industries which are more cost sensitive, like automotive, like consumer electronics, like consumer good industries, like machine tool industry, and so on and so forth. So I believe in the future, by innovating technology, by reducing cost per part, and by automating the manufacturing process, we will see a much stronger penetration outside these high value industries I just mentioned.
Yes, so that is a good thought about the industry. So how do you see a change in supply chain? People talk about big data, people talk about IoT, people talk about additive manufacturing, people talk about blockchain, and everything comes under Industry 4.0. But if somebody would ask someone about the definition of Industry 4.0, everybody's definition might change from person to person, from companies to companies, and that is something like a visionary, like let's say about there were smartphones before iPhone, but iPhone changed the complete structure of using a smartphone itself. So how do you see transformation, let's say in 2030, through additive manufacturing in the supply chain side or Industry 4.0?
Yeah. So over the last couple of years, we talked a lot about Industry 4.0, and you are right. It's difficult to grab. It's difficult really to nail down and say, what is Industry 4.0? And at the end, it's creating transparency and introducing tools which help to create the transparency and help to speed up certain processes. For example, in the engineering R&D environment, you have CID, you have CAE tools which help you to simulate, you have digital twin, digital thread, everything around the R&D process, which helps the engineer to speed up and to develop better products. And also true for production. You have MES systems, or you have inventory management systems in the after sales process. This is good. I think it creates a lot of transparency. It creates also a kind of interconnection between the different data points. You can learn a lot about your facility. You can learn a lot about your manufacturing network. But the question is this enough? Is it enough to focus on the digital layer, or do you have to combine the digital layer with the physical layer, with the physical parts? And I believe that the next step is to combine these both layers to create a cyber physical system. And therefore, you need technologies which are easy to use, which are digital and easy to connect to this digital layer. And 3D printing is a perfect technology for that. You take a data file, you put it into the machine, you print the part. You are not ready. You have to post-process the part, but it's a big step. So I believe the next step will be the combination of digital and physical. I call that digital manufacturing. And this will offer a lot of advantages, and this will also create a lot of disruption potential. Speed, time to market, speed of development processes will increase significantly. You can do a lot of more iterations. You can work closer with your customers and develop customer-specific solutions. Ramp up of production. If you know you have to produce millions of parts, it's clear that you go to, for example, injection molding. If you only have to produce a couple of 100,000 parts, at the beginning you start with additive, and maybe later on move to injection molding. And in your end-of-life process, you move back to 3D printing again. So it's a flexible way of manufacturing, a flexible way of production. Digital spare parts. Why do you need physical spare parts in a warehouse, which costs you a fortune? Develop a digital warehouse where you have digital spare parts, which you can print wherever you need them, close to your customers. And so this is just a couple of examples how supply chain will be disrupted in the future. And this will increase customer value. I believe this will reduce cost, and this will have a very important sustainability impact. Just imagine that you do not have to ship around all the parts around the globe.
So keeping that thought in mind, we have seen due to COVID something like mask or sanitizer that has become like a day-to-day usage, and nobody used to care about them. I am 1.5 year back itself, and but it became like such a turning point in our lives, that these have become day-to-day activity. So do you see any big ticket product which can come out of a 3D printer, which can be used for in day-to-day lives?
I think there are a couple of examples how AM will change our day-to-day life. Yeah? And as mentioned, it's a completely digital technology. So you have highest flexibility, and you have seen that suddenly automotive companies had been producing nasal swabs and face shields and all this stuff on machines who produced automotive components a couple of weeks ago. So this will definitely continue, that we will learn to use this kind of flexibility. We will start to think much more about customization. Yeah? In the past, it was nearly impossible because customization costs a fortune. Yeah? Imagine you want to have your own sport shoe, which is customized to your specific needs. It's nearly impossible to get one. Maybe you get an insole, but even this insole is not really customized to your need. It's a standard which is adapted a little bit to your need. But in the future, you can do that. Yeah? You can print your insole, which is perfectly fitted to your needs. You can have your customized bicycle helmet. You can have your customized iPhone. You can have your customized car. Yeah? Because individualization is, I don't want to say for free, but it's much cheaper than in the past. And this will drive innovation. This will drive new business models. This will drive also innovative companies coming up with new ideas, with new offerings. And this is based on a fascinating technology, which we have developed over the last 30 years, but which will continue to develop over the next years. And imagine how much potential is in this ecosystem. And I believe there will be a lot of innovation coming in the next years, allowing us to drive the penetration and the adoption of the technology much, much more.
So your thought has been that in our day-to-day life, we will have a modular lifestyle, and we can have customization through additive manufacturing, and it will be bespoke to our requirements. So that is a greater thought. So at the end, I just wanted to ask you what kind of an advice from a veteran of the industry for young engineers, designers, material scientists for the future in the industry who will be just joining in after this post-pandemic and who are currently working in this industry.
Yeah. You know, veteran sounds a little like dinosaur. This always reminds me that I'm getting old. But I'm taking it as a compliment. Thank you for that. So
it is all about becoming wiser.
And less hair.
So I read somewhere either you are bald or you are getting bald. So it is nothing in between.
So advice. It's always difficult to give advices. Maybe I can give some food for thought. Let's call it that way. So for me, it was always important to be open-minded, to be curious, and to listen. And there are so many smart people out there, and if you have the chance to meet them, and I had the chance to meet a lot of smart people, and if you listen, you learn a lot. And this is, first of all, what's important: lifelong learning and understanding. And there are so many topics which have to be solved. Just one example: this technology allows you to create so-called digital material. What do you mean by that? This means that you can change the material properties within one part, yeah? And at the end, voxel by voxel, melting point by melting point. You can say, okay, on the left-hand side, I have a more dense or a stiffer structure. On the left-hand side, I have a more porous structure, higher flexibility, lower weight. And you can have all kinds of gradients. So imagine the power of such a tool. But today, we are not able to use the tool because we haven't understood how to use it. So there we need a lot of smart people who want to crack the code and who find additional value, which is today still untapped. So being curious, learn, be open-minded. Do not distinguish between additive and the rest. Yeah, we need both. We need additive technologies and we need post-processing, post-treatment. And the better we understand the benefits of both, and the better we can combine these two benefits, the better at the end the manufacturing chain will be, and the more cost-effective it would be at the end. So I do not want to talk about learn design for AM. I want to say learn design for additive manufacturing combined with design for an efficient post-processing. Many parts have to be post-processed, and very often we forget that. Additional element, I tackled that already. Don't fall in love with the technology. Try to identify the business potential of the technology.
Thank you for the amazing session. Hope you have learned a lot from this session.